1.2 Muscular System Assessment, Edward Sayers. Within this PowerPoint, I will be talking about the muscular contraction process, which includes the process of performance response, the sliding filament theory, and different types of muscular contraction. First of all, I will give an overview of a standard muscular contraction. This includes everything from a stimulant traveling towards the brain down the neuromuscular junction, and then after that, everything a muscle actually does, which is the sliding filament theory. To start off the explanation, we need to have a sporting context. For a muscle to be moved, it needs to be activated by a stimulant. For this, we will use the example of a ball being thrown at you. And the sport for this example will be American football. So the ambition for you is that you want to end up catching the ball. As the ball is thrown at you, the receptors, which in this example are your eyes, will send an impulse down your sensory neuron to your brain. Your brain then makes a decision on what to do, and the brain sends an impulse down a motor neuron to your neuromuscular junction. Once at the neuromuscular junction, the impulse reaches a gap between the neuromuscular junction and the receptor sites called the synapse. However, the impulse cannot travel this gap it's in its current form, so to reach the other side, the impulse needs to change into a chemical known as ACH. Because it is now a chemical, it can travel across the synapse to the receptor sites on the other side. Once at the receptor sites, the impulse travels down the T tubules to eventually reach the sarcoplasmic reticulum, which is where the calcium ions are stored for the sliding filament theory. However, before we move on to the sliding filament theory, we need to talk about when muscles are at rest. When muscles are at rest, the Z lines on either side of the sarcomere are away from the M line, which is in the middle of the sarcomere. This shows that the muscle is completely at rest and is under no contractions at all. At rest, tropomyosin and troponin are currently covering the actin bonding sites, preventing myosin from joining together with actin, creating a crossbridge between the two. Also at rest, myosin arms are energized by ATP and are ready to create a crossbridge with the actin bonding sites. Now for the initiation of a muscle contraction. So when the impulse reaches the sarcoplasmic reticulum, calcium ions are released. These calcium ions react with the troponin, which changes its shape. The changing of the troponin's shape pulls away the tropomyosin, which is currently covering the actin bonding sites, now freeing the actin bonding sites, allowing the myosin arms to create a crossbridge with them. Once this crossbridge is created, the actin slides over the myosin, creating what is known as a power stroke. This power stroke sees the sarcomere shorten, and the Z lines on each side of the sarcomere get drawn closer to the middle M line, which is creating the contraction of the muscle. Now at the end of the contraction, the sarcoplasmic reticulum calls back the calcium ions when the electrical stimulation ends. Now the calcium ions are no longer present, the troponin and tropomyosin once again cover the actin bonding sites, preventing there from being a crossbridge between the myosin arms and the actin binding sites. The actin goes back in order to recharge its stores of ATP so that it is energized and ready for its next movement. And that is the end of the sliding filament theory. Now we can move on to the different types of muscular contraction. As you can see, there are 4 types of muscular contraction. There is concentric, eccentric, isokinetic, and isometric muscle contractions. The first type of muscle contraction is a concentric muscle contraction, and this is where the muscle contracts, as you can see in the image. During this contraction, the muscle becomes shorter. Both ends of the muscle are being drawn towards one another. An example of this could be a bicep curl, as you can see here, where you bring your arm up towards your chest and your bicep contracts and becomes shorter as you reduce the angle. The second type of muscle contraction is an eccentric muscle contraction. This is the opposite to a concentric muscle contraction. Within this type of contraction, the muscle relaxes and lengthens. An example of this could be a bicep curl, but instead of looking at bringing the dumbbell up to your chest, the eccentric muscle contractions happens as you lower the dumbbell back down to its original position, because the muscle lengthens to allow this movement to happen. The third type of muscle contraction is an isokinetic muscle contraction. This type of contraction happens at a constant and consistent speed, meaning that muscles work at the same speed the whole time. So instead of one movement like a bicep curl, this is a constant and consistent movement like riding a bike or being on a rowing machine at a gym. The fourth and final type of muscle contraction is an isometric muscle contraction. This is where the length of the muscle doesn't change throughout the entire movement. The way this works is as the force pushes against you, the resistance is equaled and is just as high as the force being generated. So whatever amount of force you put in, the same will be used against you. An example could be a scrum in rugby, because as you push in rugby, the same force is being pushed towards you by your opponents, and this therefore allows minimal movement. This brings me to the end of my presentation. Thank you for watching.